In 2014, an exploit called Heartbleed compromised OpenSSL by taking advantage of the TLS heartbeat extension. This TLS heartbeat feature allowed you to send a message to prove a connection was active. However, this extension had a major flaw. In our heartbeat response function here, we take our payload and we do a memcopy to a buffer. The issue here is that memcopy is completely unchecked. So we take a user-controlled link, a user-controlled packet, and we copy that data into a response buffer with the user's sent link. This allowed attackers to pass a packet that claimed to be larger than it actually was. I wrote an example here to show how this works. Let's say we have our data here, but instead of passing the correct length, we will pass our payload into the structure and tell the function that it is 180 bytes long, instead of the expected 4 bytes, which would give us this ping string here. If we build our code and we run it, the first thing that you can see is our data structure, the way that we have it set up, and we also have our actual payload here. So our payload is sending 4 bytes, but we're claiming it to be 180. If we had correctly claimed it was 4 bytes, we would just see this ping string here. But because we claimed it to be 180 bytes, it copied over the adjacent memory past the string, which reached the user data shown here. This is how attackers were able to take sensitive information from the server. This affected 17% of the servers on the internet, and any legacy servers that remain unpatched are still vulnerable to this day.